Hey everyone, welcome back. In this lesson we're going to continue with what we started in the last video, which was taking the graph of a linear function and then working backwards to get the equation. So just to recap what we've been doing over the past few videos, for the most part what we've done is we've taken the equation of a line and then we've turned that into some sort of graph of that linear function. So the angle of that line is determined by the slope, which we represent with the letter m. Don't ask me why, because I don't know. And the y-intercept we represent with the letter b, which is over here, which again I don't know why we represent it with b. If you're ever looking in a math textbook, you might occasionally see a textbook that uses different letters. You could see something like ax plus b or something else entirely. The letters themselves aren't that important as long as you've got one of those two being multiplied by x and then the other one being added on. It's still a linear function. So if I called it ax plus b, or if I called it I don't know, mx plus n or something, those are still valid equations for the for a linear function. And I could even swap them around. I could write even our original one, I could write it the other way, and I could swap the x and the m or something like that. I've basically written it completely backwards, but it's still the equation of a line. So if you ever happen to see an equation that looks kind of like the equation of a line, but it's got a different letter, or it's using writing them in a different order, whatever, it's still the equation of a line. So as like a bonus question on your test, I might throw in a question where I've just jumbled up the order a little bit, but that's not anything that you're gonna have to worry about just yet. And if I am planning on doing something like that, I'll be sure to give you guys plenty of examples on it beforehand. Now, of course, by plenty, I probably only really mean like 2. But yeah, if we end up getting to a point where I think that I'm going to put something like that on the test, then I'll definitely make like a review video where I go over an example similar to the one that I'm going to put on the test. Speaking of like tests and test questions and things like that, I am hopefully going to get an assignment out for you guys in the next couple of days. Since we've been doing lots of these graphing practice questions, but I was thinking about it and I figured that it's better to do a few examples all together before I just sort of send you on your way to do practice problems on your own. And same thing. So same thing for working in reverse, because what we've done so far is we've taken the equation and we've tried to turn it into a graph. So I'm thinking there'll be one assignment on that, which I'll get out in the next couple of days. But now we've started working in the opposite direction, where I've given you the plot and I've given you some line on that graph, and now I'm asking you, what's the equation? What do I write after y equals? And like that's it. I don't have any more information, and I'm depending on you guys to figure out that information. So I'm thinking we'll do 2 assignments. One assignment for going in this direction once we've got enough practice on it, and one assignment going sort of in that direction from the equation to the graph. And we've already done plenty of practice on that, so that'll be coming out first. The reason I haven't gotten it out yet is that as I'm recording this, it's Wednesday evening. I have a midterm exam on Friday, so I've got a couple things to do before that, and then I will write the exam Friday, and then hopefully Friday night or Saturday morning I will make the assignment and get all of that stuff out to you guys, and then we'll be properly like caught up to where I want to be with like in terms of assignments and everything. So without further ado, what we're going to do in this video is we're going to continue practicing going sort of in that reverse direction, going from the graph to the equation. So practice finding the equation of a line. That'll be our title. Practice finding the equation. Oops. Practice finding the equation of a line. All right, so what I'm going to do is the same way I did it in the last video. I'm going to draw the plot, and I'm going to put down a few points that I want you to plot. And it won't be the same way on the homework assignment because when I send the assignment to you guys, I will make sure to, I'll just put the lines right on the graph for you. So on your homework assignment, there'll just be an image with a line through it, and you don't have to add those yourself. But because we're working on these together and you don't have such a paper in front of you, we're going to build them together with that list of points that I give you. So just a heads up that this list of points will not be there on the assignment. This is just to help us build the question itself. So, points to plot. I'm getting ahead of myself right now because we haven't labeled anything, we haven't put any tick marks or anything like that. So let's go ahead and do that first. So we'll put a few here and make sure you label your axes. Something like that. One thing that was definitely easier working on the blackboard was trying to keep these things straight because I'm sitting at such an angle to this thing that sometimes the graph might look a little bit weird because the line looks straight to me and then I look at the camera and it's definitely not straight, or like the points aren't evenly spaced. So hopefully that's not too much of a problem. But again, if you guys have any ideas about what you think is better in here versus with the big blackboard, just let me know and I will adjust as necessary. So for now, seems like this has been working fine, so we will continue with it. Oops. You don't need too many numbers for this one. Like you don't need to extend your axes out to like 6, 7, 8, 9 or anything like that. I was just doing that on the blackboard because, you know, I suddenly felt like I had a ton of room and sort of went overboard with the size of the graph. But this should suffice for what we're doing in this video. So what I'm thinking is we'll try and get through two different ones. We'll try and get through two examples of going from the graph to the equation. So let's plot the points. Let's see. We're gonna do. We'll plot the point -1, -2, and we will plot the point. Let's see. We'll plot the point 2, 0, and you know what? We'll actually just plot those 2 points for the first question. The reason we're only going to plot those two is I want to actually highlight to you guys once, you know, at least once, that you only need to have 2 points in order to find the equation of the line, or in order to even graph the line in the first place. The fact that I've given you these points, we haven't graphed it yet, so we're going to end up using these 2 points to graph the line, so you can see that. And then from those 2 points, we can figure out the actual proper equation. So we'll do everything with just these 2 points. So just remember your x coordinate goes first, your y coordinate goes second, and we will plot those. So our first point is at -1, -2. So remember, -1, the first number is telling us whether we're moving to the left or the right, and by how much, and then the second number is telling us whether we're moving up or down, and by how much. So the first one is telling us we're moving 1 unit, and we're moving 1 unit to the left because of this negative sign. So that's 1 unit to the left of the origin. So starting here, we go 1 unit to the left, that brings us here, and that takes care of this -1, but then we have to go down because of this minus sign, and we have to go down 2 units from where we were just now, so from this -1. So we started out from the origin, we go over here to -1, that's in the x direction, and then in the y direction we go down 2 units to about here. I haven't put the tick marks just because the points that we're plotting for this particular question are really close to the axes. Sorry, not tick marks, the sort of the dotted lines that go through the middle. I haven't done that for this one, but you know what? I will just in case it ends up being helpful when we're graphing it, when we're graphing the actual line. So I'll put some of those through here. Is that reasonably straight? Okay, it looks reasonably straight on the bottom, but I'm going to redo this part. Something like that. Okay, something like that looks good. Again, this stuff with the vertical grid lines is totally optional with these dotted lines. For you guys, it's just that for me, with the angle that I sit at with respect to the board, it's hard for me to gauge when something is in line with a particular point on the axis. And that's an example of it right there. I completely missed the 4 with that dotted grid line right there. And actually, I kind of missed it again, but I don't think it's super important for this one. I'll just fix that little section though. Something like that. All right, and then we've got some horizontal ones, and then we'll actually plot our 2 points. So sorry, I kind of left that in the middle, but now I'm feeling like just for the sake of completeness, we should sort of have these grid lines in here. That one is definitely not as straight as it could be. And that one kind of missed the number, but we're not really using the space down here anyway, so don't worry too much if your grid lines happen to be slightly out of line with the numbers. But there we go, we got something like that, and we've plotted our first point. -1, -2 is right about here. So now we can go ahead and plot our second point, which is this one right here. So our point is 2, 0, 2, 0. So remember, the 2 is telling us where we're moving in the x direction. Since it's a positive number, we're going to be moving to the right, and we're going to be moving 2 units to the right. So from 0, we move over 2 units to the right, and that'll take us over to here. And then the y coordinate, the second number, tells us if we're moving up or down. It's a 0, so we're not moving up or down at all, which means that from the origin, we just move our 2 units to the right because of that 2 in front, and that's it. That's where we put our dot. So we've only got 2 points here, but this is actually enough to draw the entire line. So all we need to do, if you're doing this with a ruler on your page, what you can do is just make sure that it's lined up with those 2 dots, and then just extend the line out to the edges of the graph. I'm going to see if I can find like a stick or something in here that's long enough to sort of highlight what I'm talking about. Let me see, I might have something up here. Okay, well let me see if one of these will sort of do the trick, what I'm looking for. Okay, this is dark enough as well. Okay, so here's just some random notebook. Oh, this is a previous lesson plans notebook. Great. So what we have here is, if I wanted to use this to draw a straight line, I'm not going to use it to actually draw the line, but if I just line it up with these 2 points, like that, then I could just extend my line to the edges of the notebook, which would reach basically the 2 ends of the graph. So I don't need to line it up with a whole bunch of points. I just need to find 2 points that are on my line and then graph it from there. So this is enough information for, if I wanted to, I won't be able to hold the notebook steady and all of that while I'm trying to draw the line, but just to give you an idea of what I mean, if I hold the notebook here like this, I could then use that to draw my line across right there, and I would be done. I'm not going to use the notebook to do it though, partly because it's hard for me to hold everything up, and partly because the notebook erases the stuff on the board when I do that. So I'm just going to sort of freehand it and hope for the best. But if you have a ruler, use a ruler. It's always preferred that you use a ruler if you have the opportunity to do so. So yeah, my lines are always a little bit wonky in that corner over there, but I think you get the rough idea of what's going on. So we've got our 2 points and we've used them to draw the entire graph. So that's hopefully proof enough for you that we can graph the entire line based on just 2 points. And what we're going to do now is I'm going to get rid of this points to plot business, and we're going to work on figuring out the equation. So in order to figure out the equation, we're going to start with writing out the general form of the equation of a line, which is y equals mx plus b. So that's the general form, is that I haven't filled in any of the numbers. This is just sort of like a bare bones structure of what it's supposed to look like, and you have to fill in the numbers yourself. So that's the general form that we're dealing with here. So different types of functions will have different general forms, and for a line, it looks like this. So now let's start off by trying to figure out our slope or our y-intercept. Now here's the struggle with trying to find the y-intercept. We haven't actually been given a point that lies on the y-axis, right? I haven't given you a point where I've told you some number for x and 0 oh sorry, I've done that backwards. I haven't given you a number or a point where I've got 0 in place of x and then just some random number for y. Because if the x coordinate is 0, that means I'm not moving left or right, which means I have to be only moving up or down, which means I'm staying on the y-axis. All right, does that make sense? I don't want to rush through that point. If the x coordinate is 0, that means you're not moving left from the origin and you're not moving right from the origin. So all that you could be doing is either you're staying put, or you're moving up, or you're moving down. If you're only moving up or down from the origin, you're somewhere along the y-axis, right? And if you're sitting on a line that's passing through the y-axis, wherever it passes through that y-axis is your y-intercept. So as soon as you find a point where the x coordinate is 0, this coordinate over here, the y-coordinate, is always just b, like the y-intercept b, the same thing. That might look like a 6. I don't mean it as a 6. It's lowercase b. It's your y-intercept. So if your x-coordinate is 0, your y-intercept is the y-coordinate of that point. Problem is, in this particular question, we haven't been given a point like that. We could sort of eyeball the graph and try to wing it, but what I'm going to do is I'm actually going to show you a different technique to find the y-intercept. So, in order to find the y-intercept by using this other technique, we're actually going to, instead of starting with the y-intercept, we're going to have to start with the slope. So we're going to forget about the y-intercept for a second, and we're going to focus on the slope. I'm going to actually get rid of the title because I need the extra space. Okay, so the 2 points that I gave you were -1, -2, and 2, 0. Okay, so now our slope is our rise over our run. And actually, maybe we won't do 2 examples in this video. Maybe we'll keep it to just this one because I'm going to show you something else that's new in this lesson as well. So I'm going to take this equation of a line and throw that over here. We already know what it is, but I'm just going to move it over there to get it out of the way, but to still have it somewhere on the board. So we know our slope is equal to our rise over our run. I'm just rewriting what I have down below so that I can erase it from there. Now, figuring out the rise and the run, what we've been doing so far is we've been looking at the graph and we've sort of counted out, oh, okay, I have to move up this many units and then I have to move over that many units in order to get to my point. And that's not a bad way to do it, but it can be a little bit of a time-consuming way to do it. So what I'm going to do is I'm going to show you a formula that you can use if you're feeling comfortable with it especially now that we've done our algebra unit. Um, you should hopefully be feeling a little bit comfortable with what I'm about to show you, but it's going to look a little bit scarier than what we've done so far, so don't worry about it if it's something that you don't really feel like using right away, but I do recommend that you try it. So, an equivalent way to write out that rise over run business is to write your equation like this. So to find your slope, I'm going to write it out and then I'm going to explain it. So it's y2 minus y1. Now notice I've written the 2 and the 1 really small, so I want you to write them just as small. So there'll be little like subscripts on the y's. And then same thing for your x's. x2 minus x1. So we're going to write them as little subscripts there. And now I'm going to explain what exactly this x2, x1, y2, y1 business is. So x1 and y1 are, you can label the points however you wish, but we're going to label one of the points as point number 1 and one of the points as point number 2. Now I prefer to label the leftmost point as point number 1, but that's just sort of a personal preference, so you don't have to do that, but I'm going to do it that way for this video. So our leftmost point is this one, -1, -2, so I'm going to call that P1. That's our point number 1. And then the other one, 2, 0, that's point number 2. So those are our points for this particular question. Now, x1 is basically the x-coordinate of the first point. Okay, so x1 is the x-coordinate of the first point, so that would be the x-coordinate of the first point, so that's this -1 over here. x2, I'm going to erase that right there. We'll do this in order. We'll do this in order from the numerator. So we'll start off by drawing our line for the fraction, and then we'll go through this step by step. So y2 is the y-coordinate of the second point. So our y-coordinate is always going to be that second column in there, right? Somewhere in there. So it's either the 0 or the 2, the -2, but it's the y-coordinate of the second point. So we find point 2, and then we find the y-coordinate of it, so that's going to give us 0. So in place of y2, I'm going to put a 0. All right? Then we put a minus sign. Now we take the y-coordinate of point number 1. So we had 0 as the y-coordinate for point number 2. -2 is the y-coordinate for point number 1. So I'm going to take that, and I'm going to throw it right here. I'm going to put it in brackets because we've got two negative signs sitting side by side, and we don't really like that. And so now we can move on to the x-coordinates. So far, this thing here, that's y2, that's our y-coordinate for the second point. This -2 right here is our y1, our y-coordinate for the first point. Now we're going to do the x-coordinates. So x2 is the x-coordinate of the second point. So that's this right here. So we found our point 2. Take the x-coordinate, that's +2. So we write that in there. Stick a minus sign in there, that's this minus sign right here. And then our x1 is going to be the x-coordinate of the first point. So that's this -1 right up here. So again, I'm going to throw it in brackets because we've got two minus signs sitting next to each other, and we don't like that. So there we go. And what this is going to let us do is figure out the slope by using 2 points. Now first we'll calculate what exactly the slope is, because we've got a whole bunch of numbers in here. Then we'll talk about why this equation works. So what we have here is we've got 0 minus -2. Now if you remember, subtracting a negative number is the same as adding a positive number. So 0 minus -2 is the same as doing 0 plus 2, which is equal to 2. And then down here we've got 2 minus -1, so that gives us 2 plus 1 effectively, right? So that gives us 3. Right? We've got 2 minus -1 is the same as doing 2 plus 1, so that's going to give us 3 right there. Let me just make sure. I was just double checking my math and I thought maybe I did something wrong, but I don't think I did. Okay, I guess we're good. I think I'd pictured giving you guys a slightly different question, and then I gave you a different one from that, and I was confusing myself, but I think all is good. So then we've got this fraction here as our end result. So this is telling us that our slope for this particular um, function is 2 over 3. Now let's think about why this works. If we go back to using this equation, our rise over our run, we would still get 2 over 3. If you use the graph to figure it out, you start from your first point, you go up 2 units, so that's our rise. That's our rise right here. And then we go across 3 units. So we go 1, 2, 3, and that's our run. So 2 over 3 is our slope for this line. But why does this equation work? Well, what we have is, I'm going to erase some of this extra stuff just so that it doesn't get too busy. What we have here is on the top of this numerator right here, what this is doing is it's figuring out the difference. Remember, the answer to a subtraction question is the difference. So it's finding the difference between the two y values. Now the y values only tell you how high or how low you are on the graph. They don't have anything to do with left and right. If they're only talking about how high or how low something is, they're only talking about the rise, right? If you're only looking at the y coordinates, that's the piece of information that's going to tell you if your rise is 1 or 2 or 10. That's all going to come from just comparing those two y values. So if you just look at our two y values from over here, that'll tell you whether your rise is 2 or -2 or something else. And the way you make sure that you don't get the positive and negative signs wrong is you don't have to do the second one minus the first one. You could do the first one minus the second one up here if you want, as long as you do the same thing down here. So as long as you're consistent with your setup, you can do it either way. You could do y1 minus y2 on the top, as long as you do x1 minus x2 on the bottom. So you just can't mix and match with doing the numerator one way and doing the denominator a different way. Then you'll end up with a minus sign sticking out in front of your slope, which is not correct. But yeah, basically, as long as you keep, so right here, if you look, we've got 0.2, 0.2's coordinate goes first, and then 0.1's coordinate goes second. And that's just the way we set it up. So if you could make an oval like that, that connects the two coordinates of 0.2, and a different oval like that, that connects the coordinates of 0.1, and those ovals don't cross each other, you set it up just right. But so now back to figuring out why it works. So if we compare the two y values, that's only talking about how high or how low something is on the graph. So that's talking about the rise. Now, if you look at our x coordinates, well, the x coordinates don't get any say in whether something is moving up or down. They only care about whether things are moving left or right. So if you just compare the x coordinates of two given points, you're only caring about the run, how far across in the horizontal direction that you have to travel to get from one to the other. So the x coordinates are basically the difference in those x coordinates tells you the run, and the difference in the y coordinates tells you the rise. And so basically, this is a mathematical way to write out rise over run, because we're not going to write out our equations with words all the time. So if once we start writing everything more mathematically, this is the way that you could calculate the slope. So this is something that you should absolutely try your best to know and to understand. Now, it's one thing to memorize the equation, which when it comes to like doing a test or an assignment or whatever, sure, it's convenient to just memorize the equation. But if you understand why the equation is the way it is, then you'll be able to, even if you forget how the equation exactly is set up, if you understand how it works, you could figure it out on the spot on your test. And I can attest to this. This happened in my astronomy course in first year. I didn't study for the midterm exam, but I understood the way that the professor, had taught all of it. So on the test, I came up with all of the equations that I needed just by thinking about the question. So it's the same thing here. If you forget how this equation is set up, you can figure it out on the test as long as you understand why we have these letters and numbers where they are. So as long as you understand that the difference in the y values tells you the rise, and the difference in the x values tells you the run, that's all the information that you need to be able to figure out the slope, as long as you have 2 points. And you're in luck, because we do have 2 points. We've got our point 1 and point 2 right there. So now we're still not done with figuring out the equation of this line. So far, all we've done is we've taken care of this m bit, and now we still have to worry about finding the y-intercept. We still have to find b. So I'm going to erase some of this. I'm going to write maybe down here, just because it's a little bit of empty space. I'll write in m is equal to 2 over 3. Now, here comes another juicy new piece of information. We are going to now figure out a new way to find the y-intercept, because we can't simply read it off one of our points. I haven't put a point on the graph and told you, the coordinates of this point are 0, comma, and then some number, because that would just be the value of your y-intercept, and we don't have that luxury in this question. So what we do have is we have this slope down here of 2/3. We know m is equal to 2 over 3. So right now, our equation for our line looks like this. Y is equal to 2 over 3 x plus b. And we need to figure out what b is. Okay, so here's where it gets a little bit interesting. You've been given 2 different points. What we're going to do is we're going to take the x-coordinate of one point and its corresponding y-coordinate. So we're going to choose one of the points. Either we're going to choose point 1 or we're going to choose point 2. We're going to take its coordinates and we're going to plug those coordinates into the equation. And I'm going to show you how that works. So just to sort of give you a full idea of how this works, we're going to take point 1, even though it's technically the more complicated point. I'll actually show you the same thing with point 2 afterwards if we've got enough time. But we'll take point 1, we'll take its coordinates and we'll plug them into the equation. So in the next line, I'm going to put an equal sign, but instead of putting y on the left side, I'm going to take the y-coordinate of the point. So we're dealing with point 1, so I'm going to remove this circle around point 2. There we go. So we're going to take the y-coordinate of point number 1, so that's this -2 right here, and we're going to write that in place of y in the equation over here. Okay, now on the right side, the 2 over 3, that came from our slope, so that can stay. But instead of x, I'm going to take the x-coordinate of our point, so that's this -1, and I'm going to put that in here. And those two are being multiplied together. So remember, if I put 2 numbers side by side with brackets, they're just being multiplied together. And then we've still got plus b. We still haven't quite figured out b, but now everything else is numbers. And we've only got one letter sticking out over there. So this is enough information for us to figure out what that letter is. So let's start off by going through that multiplication. So we've got -2 is equal to any number times -1 is just the same number you started with, but with a minus sign. So we get -2/3 plus b. All right, and so now we want to solve for b. We want b to be by itself on one side of the equal sign. So what I'm going to do is I'm going to take this -2/3, I'm going to chuck it over there. It's going to become a +2/3 because it's being brought over the equal sign. And at the same time, just to save us a step, I'm going to convert this -2 into a common denominator, because we're going to end up adding these together. So don't write this. Actually, you can write it. What we've got now is -2 plus 2/3 is equal to b. Okay? But what I'm going to do is now I'm just going to erase this -2. I'm going to change it into a common denominator, into a fraction with a common denominator with this one, because we have to add them. So in order to do that, we need to have a denominator of 3. So our numerator for that is going to have to be 6. And hopefully you guys can see why it needs to be 6. But it's basically because we started with a 2 or a negative 2 sitting out in front, right? So we basically had a fraction of 2 over 1, and we needed the denominator to be 3. So we going from one denominator to the other, we had to multiply by 3 on the bottom, so we also have to multiply by 3 on the top, and that should give us a 6. So we end up with negative 6/3 plus 2/3 is equal to b. I'm running out of room down here at the bottom of the board, so I'm going to have to go up and erase maybe this starting line, and we'll go back into this space over here, and this will give us our value for b. If you go ahead and do that addition, you will get that b is equal to negative 4/3, or negative 4 over 3. Now, when we're dealing with this stuff with lines, you don't have to, I don't care if you leave this as an improper fraction or convert it to a mixed number or the other way around. But all that I care about is that you have the right value. You could do this as a decimal if you wanted to. So you could also write this as negative 1.6 repeated. And that's not 1.6, 1.3. Sorry, my mistake. Negative 1.3 repeated is the same thing as this negative 4/3. So whichever way you prefer to write that down, you can write it down just like that. So now we've figured out, let's sort of take a step back and see what we did. So we took our equation of our line, so that's this y equals mx plus b. We used the rise and the run to calculate our slope. So this m was dealt with first, great. Then we took that slope, plugged it back into the equation, and took the coordinates, the x and y values, for one of the points. So you can't take the x value of this point and the y value of the other point, or the x value of that one and the y value of this one. You can't mix and match. If you're taking the x value of one point, you have to take the same point's y value, and we plug those into the equation. So this negative 1 came in here, and this negative 2 came in right here. And there we go. I know there's just arrows flying around the board now. But so that's where, so this is our x coordinate and this is our y coordinate. So we plugged those in, and then it's just a little bit of math and moving some numbers around, and boom, we've solved for our y-intercept. So we can write down over here, so our slope is 2/3 and our intercept is negative 4/3, like that. And so now we can, just as our last and final step, we can sub that in to our equation that we started with, our y equals mx plus b. We can sub it all in and get a proper final equation for our line, which is y equals, well, we need our slope first, so 2/3 times x. So that's dealing with the m and the x, but now we know that b has to be equal to negative 4/3. So then we'll put in minus, remember minus because the b is negative, minus 4/3, like that. And that would be your equation of a line. Now, as a teeny weeny little homework exercise, this isn't like, like an assignment thing or anything like that, but until I get the assignment out to you guys, and just because we've done a lot of stuff in this video, just as a way to check your understanding, what I'm going to do is I'm going to rewrite this equation that we just found, on the right. I'm going to rewrite that over here, and I want you to, if you don't understand it immediately, I want you to really think about it and figure out why I'm allowed to write it the way I'm about to write it. So I could also write out this equation that we just got as something like, let's do, how complicated do I want to make this? Let's see, I could also write that equation as 3y is equal to 2 times x minus 2, I believe. Make sure that's right. Okay, I think I've done that right. If I have done that wrong, you guys will know by the fact that none of you will be able to figure out why it is the way it is. But I believe I've done this right. And I will double check that at the end of the... No, I'll double check that right now. So that would give us this. That would give us that. Yeah, okay, I think I've done this right. Only reason I'm being a little extra cautious is that it's almost midnight, and this is the time that I make mistakes when I'm doing my math. Yeah, so if it's not immediately evident or evident within a couple of minutes why this is a totally valid way to write out that equation, I want you to spend, not that long, spend 10, 15, 20 minutes at home trying to figure out why this is still a valid equation of a line. Now, on the test, you're allowed to write it like this and leave it this way, but as an example of something I could ask you to graph, I could ask you to graph the equation, I could ask you to graph a line and then tell you that the equation of the line is something like this. So basically what you need to do is you need to take this equation, and as one of my professors would say, you need to massage this equation until it looks like that, something that's a little bit more familiar, something that we know how to work with. And so you would start with this. This is what I would give you in the question. You need to go from this form into that form, and then you could graph that one. So I will, if I remember, I will take this up in the next video. I'll explain why you're allowed to do it that way. But if I forget and you guys can't figure it out, then get in touch with me somehow and I will make a video to explain that. Or if it's like an email, I'll respond to that email and explain it that way. But yeah, so that is everything for this lesson. I know this one is a tad longer than ones we've done before, but I just wanted to make sure that we're really getting comfortable with some of the ideas here. I don't want to rush through any of this. The next video will hopefully be out tomorrow night, but if not, it'll either be a video that comes out early Friday morning or an assignment that finally comes out Friday morning, because the assignments actually take less time to make than these videos. So I don't know why when I'm short on time I decided to make another lesson, but whatever. We'll figure it out. So in the next day or two you should be getting another one of these lessons and or an assignment, and this is your little homework exercise to kind of keep you busy until you get that assignment. So as always, if you have any questions, get in touch with me. Otherwise, I will see you all in the next video. Have a good one.